Well, thank you very much, and good afternoon. Thank you for inviting me to participate in this hearing today. I am an atmospheric scientist, and over my about 25-year career, my research has focused primarily on the changing Arctic system and how it connects with the global system. And as a scientist and a mother of 2 teenagers, I'd like to tell you about the top 5 things that keep me awake at night. The first, and we've heard some of this already today, is in the past year, we, as a global humanity, have broken 2 momentous records. First, we have, by burning fossil fuels at a very fast rate, we have emitted the most carbon dioxide into the atmosphere we've ever seen before. This has led to our carbon dioxide levels in the atmosphere being the highest they've been in at least 800,000 years, probably more like 2.5 million years. And we know that the last time the carbon dioxide levels were this high in the atmosphere, the global temperatures were several degrees warmer and sea levels were tens of feet higher. So why hasn't this started to happen already? Well, we know why. It's because it takes a long time for that heat to be conveyed into the ocean. The ocean has a very high heat capacity. It takes a long time to warm it up. The ocean is the flywheel in the climate system. And we've added this carbon dioxide so fast that it just hasn't had time to catch up yet. But it is starting to. According to a new UN report that was released last month, this past decade of the 2000s was the warmest on record. Not only in the record of digital temperatures or thermometers, but also going back probably 2,000 years of proxy records. But we know that we've heard many times already this morning that the air temperature, the surface air temperature, has slowed down in its increase over the last 15 years. But we know why. Here's the real data and the real facts. There are natural fluctuations in the ocean circulation that modulate this increase in temperature over time. Things like El Nino, for example, we know tends to increase the global average temperature, whereas La Nina has the opposite effect. Over the last 15 years, we've had a great number of La Ninas. This has tended to cause the surface temperatures globally averaged to decrease somewhat. But we know this is going to rebound because there will be El Ninos again, and we'll see that heat that Dr. Cullen talked about returning to the atmosphere from the ocean. The heat is there, and the warming has not slowed down. The second thing is that all this extra heat that was trapped is causing all of the forms of permanent ice in the Arctic to disintegrate. For example, let me just talk about sea ice. The other things would be permafrost and ice sheets and so forth. The sea ice, as of last summer, was 3/4 gone. 3/4 of it is gone in just 30 years. And the only explanation is the increase in greenhouse gases in the atmosphere. The third thing is that the pace of sea level rise is accelerating. We know this is due to the warming oceans, and when the ocean warms, they expand. We also know that it's because of these disintegrating permanent ice forms in the Arctic, adding mass to the oceans. As the oceans warm, they also allow more evaporation into the atmosphere, about 7% over the last 30 years. This provides more fuel for storms, because when it condenses, it releases heat, and also for the heavier precipitation events that have been observed over the Northeast. The fourth thing is that the Arctic has warmed 2 to 3 times faster than the rest of the Northern Hemisphere. This is due to sea ice loss and also this water vapor increase. That temperature difference between the Arctic and areas farther south drives what we call the jet stream. This is the high-level river of air over our heads that creates weather, steers weather, and as the Arctic warms faster, it's decreasing this temperature difference, and it's causing the west-east winds of the jet stream to slow down. This has been measured. As that jet stream slows down, it takes on a wavier path as it travels around the Northern Hemisphere. We can measure this as well. Those waves cause the weather that we experience here on the surface. And if those waves get bigger, which we see that they are, they tend to move more slowly from west to east, along with the weather that they create. So this is increasing the likelihood of extremes that are caused by slow-moving weather patterns. And finally, number 5 is climate misleaders. What I call climate misleaders, these are people who are deliberately ignoring and misconstruing the science in an attempt to convince you all and the public that either human-caused climate change isn't happening or that it's nothing to worry about. And my time is almost up, but what I want to say is that we know they rely on models and they're picking specific variables from models and illustrating that they're not working right. We know that the models aren't perfect, and we know also that they're mostly right. The sign that they're telling us is correct, and we can depend on that being crystal clear. And I would agree that we have no more time to wait. We have to start to act. Thank you.
Thank you very much, Dr. Francis. Dr. Doney.